Hi everyone, I'm Lionel. I work at our studio in the tidyverse team, and I'll be talking about reusing tidyverse code. So the kind of packages that will be useful for is the data manipulation and visualization packages like dplyr, tidyr, or ggplot2. And what they have in common is that they are domain-oriented, they have language-like interface, and especially they have the data is the most important scope for them as opposed to the workspace. We'll see what that will mean and what implications it will have. So, for example, dplyr is a package that provides a set of verbs for data manipulation. So if I have a data frame, I can filter it for specific month and day. I can add new columns to it from old columns. Or I can group it by a grouping variable and then summarize it with a summary function like min. And in this case, I'm taking the mean of our delay within each level of month. And so in this kind of interface, data is the important scope because you can refer directly to your data frame columns as if they were in the workspace. And the way that works is that we change the context of computation. So in dplyr, that can mean something very general, like we can translate your computation to a SQL query and then execute it in a database, a SQL database. But what we mostly what we do with dplyr is that we transport the computation inside a data frame, and so that's what means that you can use the data frame columns directly instead of having to be specific about it. So we call this data masking. So we have it in tidyr, in dplyr, in ggplot2 as well, because the AES function is a data masking function. You can refer to the data frame columns in them. It's in base R2, like the base subset and transform functions, which are actually a major source of inspiration for dplyr, written by Peter Dalgar. The modeling formulas are data masking too. You can refer to data frame column there. And then in data table, you have data masking built in the subsetting operator. So it's a very general feature of R. And the thing is that while data masking is optimized for interactivity and writing scripts, where often you create single usage pipelines for data transformations, sometimes you still need to reuse code because you don't want to repeat yourself. And so you want to create a function to reuse command patterns. And so let's say that we have here a command pattern here. We group a data frame by some variable, and then we take the average within levels. So that's a case where we want to reduce the repetition. We want to create a function. So the usual way to go about it is to take your piece of code that is repeated, wrap it in a function. You take arguments for all the variable parts. So here we are taking a data frame. We are taking one variable to take the mean of, and one variable to group by with. But if we do it this way, the usual way, you get this kind of errors with data masking functions that some kind of variables cannot be found. So to understand why that's the case, we need to look a bit into how data masking works. So on the left, we have a normal function like list. And if you try to refer to data frame columns in there, it cannot find them because they are not defined in the workspace. And the arguments that you pass to normal functions, they are computed as soon as needed, and they are computed in the workspace, not in the data frame. And so how data masking functions work is that they capture blueprints of your arguments of the computations. They don't ask for the results right away. And then we transport this and compute it in a data mask. And so that's what happens here. Group by is trying to capture a blueprint, and in this case, it contains a column by instead of what the user has supplied, which is month. So data masking is this great feature of R. It's great for writing data analysis code because you can focus on your data tasks rather than on how it is structured, data structures. And the upshot of this is that creating functions is harder. So we are going to see a few ways of doing it. We are going to use the tidyverse framework, which is implemented in the Erlang package. It powers all the data masking functions in the tidyverse, and it provides flexible and robust programming for data masking functions. And it has some kind of strange syntax, like bang bang, the big bang, and a funny function name like enquo. And it requires to learn new concepts, like quasi-quotation and closure. So it can be quite an involved task to get into it. So that can be a lot for most people, and we have come to realize that okay, you shouldn't need to be an expert in metaprogramming to create simple functions. So we are changing our strategy with tidyverse. We are now trying to focus on easier patterns in our documentation, and also we have added this new operator curly to Erlang to embrace arguments, and it should make it easier to create tidyverse functions. So we are going to see how to subset the .data pronoun and how to pass dots. So these are existing patterns that you could use with the existing Erlang package. And then the third one will require the new version of Erlang. I will start with .data. And let's say that on top you have this typical data masking syntax where you take the mean of price, which is a column in your data frame. Well, in all the tidyverse functions, you can do it equivalently as subsetting .data with $. The first, all these expressions are completely equivalent, including when you have the name of a column as a string in a variable, and then you use the double bracket operators to subset it. And that's what we are going to use to create a function. So here we have our pipeline, create a function around it, and then we'll take column names as strings, and we'll pass them to the double bracket operator to subset .data. And so now we have a function that takes strings, and that allows you to create a function around tidyverse pipeline quite easily. Also, it's a normal function, it's not a data masking function that you have just created, and so you can store the column name in a variable. It works, there's no data masking problem. And so that can be helpful if you are collaborating with colleagues that don't know about data masking. That can make things easier. The second way is to pass the dots. So here we have this group by call, and we are going to take the number of rows within each level. And so we get this data frame of counts for each level. And we have repetition in our code, and we'd like to create a function. So one very easy way is to take your pipeline, wrap a function around it, take dots, and you pass the dots to group by. That's all it takes. So passing the dots is easy, but it also has nice properties because the function that you pass the dots to interprets all the inputs that you pass through the dots, and so the behavior of this function is inherited. And in particular, you get automatic data masking. Secondly, you can pass names with dots in the argument, so you can override the default names, which can be helpful. And you can, of course, pass multiple arguments through dots, and that makes your function that it takes multiple inputs. So here we see that with our new function, we have a data masking function. We can pass cut, like refer directly to it. We can create new columns on the spot because that's what group by does. So here, for example, we have a caret column, which is a continuous variable, and we can on the spot cut it into three level factor and group by this and take the count. So you can see the default name is informative. It tells you how the columns were created, but maybe not so easy to work with afterwards because you have these backticks because of the special character inside the column name. So what you can do, since we take dots, you can supply a name with your input, and that will override the default name for the data frame, so that's quite useful. And finally, it takes multiple inputs. So here we are taking the counts within the entered section of 3 factor variables. So finally, embracing arguments. So that's a new syntax in the last Erlang version. And with this curly operator, you can substitute function arguments as you take them. It's inspired by the glue package from Gmaster, and the idea is a bit the same. So with the glue package, you can build strings from components by substituting variables that contain other string. And that's a bit of the same idea. So if we have this pipeline, we create a function around it. And for every argument that can contain data frame columns, you just use this embracing operator. And that's it. You have a full data masking function. You can refer to data frame columns directly. You can create vectors on the fly. So here we take the mean of price rescaled by 1,000 within the levels of carat that we have created here. So that's a new syntax in the last version. If you know a bit of tidyverse, it's just a shortcut for bang bang enquo. That's all it is. And all the idioms, they won't go away. They are still useful for more complicated patterns. But we hope that the curly operator will be easier and more intuitive to quickly create functions around tidyverse pipelines. So to sum up, we have seen that data masking is this great feature of R that can make it harder to program with, even though it makes it easier to explore data. But there are 3 easy techniques for creating functions around tidyverse pipelines. You can subset the data. You can pass the dots. You can now embrace single arguments. All the harder techniques can still be relevant if you want to do something more complicated. And we have a book in progress at this URL there, tidyverse.org. And so these are my slides.
Thank you. We have time for a couple of questions.
Hi. Thanks for a great talk, and it's great to see that efforts being made to make it easier to program using tidyverse and tidy evaluation. My question is there a way using this new technique to allow an argument to be either a character or an object? And if you use this technique, would you have to use entirely one approach or the other?
No, you have to choose one or the other approach. There's no robust way to figure out automatically what the caller wants. So it has to be one or the other.
Here's the question.
Hi. I write a lot of functions that are using tidyverse but working against a database. And I have a lot of problems making those functions play nicely when I have DevTools check because the .data syntax doesn't work and I'm trying to get rid of all my notes in DevTools check. Is there any way that this is likely to help me be able to rewrite those pieces of code so that I don't keep getting those notes when I do a check on my package?
Now you have to declare them to R command check with utils global variables.
It's when I'm working against the database, it doesn't seem to work for me to. Oh, okay. Okay.
But yeah, with dot data, normally you don't get the notes. But with curly you would need to declare the pipe. So.